Hey guys, this is Coach Lowe, and we're going to talk a little geometry today. This is A3 special right triangles. One of my favorite things to talk about because this leads us into trig. And you know, we've already talked about how much I love trig. So this is going to be really fun and a lot of why things work the way they do in the next several sections, which I know you guys love that. So this will be good times. All right, so first of all, there are two special right triangles that I want to talk about today, and one of them is the 45-45 right triangle. So that means angles are 45 degrees, 90 degrees. So 45, 45, 90, which means, so you'll hear me say this, 45, 45 right triangle. So 45, 45 right. You hear me say that? Know that I'm talking about a right triangle that has angles of 45 degrees, 45 degrees, and 90 degrees. All right, so first of all, before I give you this theorem, I want you to draw a square on your paper. Why didn't I use the square tool? I don't even know. Let's do that. Well, you can't, but I can. All right, so would you agree that all of these angles on this square are 90 degrees? Hopefully you said yes. All right. Let's say that the side length, we don't know, it's just x, but we also know that all sides are the same length. All right, so I'm going to draw a diagonal because I want a triangle. We're talking triangles, not squares, right? I'm going to draw a diagonal, and now I have two congruent triangles. When I draw this diagonal, that is an angle bisector also, so this is 45 degrees and 45 degrees. This is 45 degrees and 45 degrees. My sides are still x, 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 and x. All right. I'm going to peel off or pull apart this triangle right here. All right, so I'm going to take that one out and I'm going to pull it over here and we're going to do a little examination on it. All right, so side lengths we know are congruent and we don't know how much they measure. We've just put x on them. We know this angle is a 90-degree angle. So we are dealing with the right triangle, and I have 45 degrees on both. So now you see the 45, 45 right triangle. All right. We know these two side lengths, but we don't know the length of the hypotenuse. Well, we can find the length of the hypotenuse because we know the Pythagorean theorem. The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So I have a squared plus b squared equals the hypotenuse, c squared. So I have 2x squared, there are two of them I'm adding, equals c squared. All right, I am solving for c. I want to know this side length, so I shall take the square root of both sides. The square root of 2 can't be simplified, so I'm going to leave the 2 underneath, but look at the x's. The x's are squared, and we know that the square root of something squared, those are inverse operations, they undo each other, so it can come out as x. So c, the length of c, is whatever this side length is times the square root of 2. So if I say, hey, the leg is 5, you know this side is 5, this side is 5, and this side is 5 times the square root of 2. Or if we say this side is 10 times the square root of 2, we know this side is 10 and this side is 10. Or if we say this side is 12, we can find these sides by setting these two equal. So check this out. X times the square root of 2 equals 12. I'm trying to solve for x because I know this side is already 12. I need to know the length of these guys. I divide by the square root of 2, which can be scary for a second. So x equals 12 over the square root of 2. Now, we do not like to leave square roots in the denominator, so we will rationalize here. Rationalize means I'm going to get rid of the square roots out of the bottom. None of those. So what would get rid of the square root of 2 when I multiply? Well, if I multiply by the square root of 2, that will get rid of it. Now I have square root of 4, which is 2, so that's beautiful. I also have to do that on the top. Do you see that this is actually a big fat 1 here? Because square root of 2 over 2 is 1. So I'm really multiplying by 1. And it's going to clean up the bottom of this fraction. So I multiply straight across. This is 12 times the square root of 2. I multiply straight across the bottom. It's the square root of 4, which we know is 2. And now I can reduce these guys. You can't reduce here. This is locked underneath. Remember, can't go out, no date night. So it has to stay home. Sorry. But we can reduce here. So 6 times the square root of 2 is my final answer. So the legs here would be 6 square roots of 2, 6 square roots of 2, or 6 times the square root of 2. So I have 6 square roots of 2, 6 square roots of 2, 12. All right, let's work a few problems here. All right, so the first problem. I see I have a 45, that makes this one 45, 45, 45 right triangle. The first thing you need to ask yourself is, did they give me the leg length or the hypotenuse length? So here's the hypotenuse and straight across is an X. So I'm trying to find the hypotenuse. I'm going to go ahead and write this is X, or I'll use L on this one since I already used X. This is a leg, and we know the ratio is we take the leg and we multiply it by the square root of 2. That's the ratio of these sides. So I know the leg is 48, which makes the hypotenuse 48 times the square root of 2. That's the shortcut. Long way would be do this. You can use Pythagorean theorem because we're dealing with the right triangle. So we would have 48 squared plus 48 squared equals x squared. Square 48, add them together, take the square root, you're going to get 48 times the square root of 2. Yay, us. So think about that. 48 times 48 plus 48 times 48. I have two groups of 48 times 48. Take the square root of both sides. The 48 can come out. The square root of 2 has to stay in. Little shortcut even on Pythagorean theorem. So we don't have to do all this work because every single time that pattern is going to happen. We showed that with just variables on the last page. So yeah, you don't even have to do all this stuff, which is awesome. So determine if they've given you a leg, and this is 48, this is 48, this is 48 times the square root of 2. Every time you have a 45, 45 right. All right, so what did they give us here? They gave us the hypotenuse, didn't they? So this is x, this is x, this is x times the square root of 2. All right, we need to set these equal to each other and figure out what x is. We're trying to solve for x so we know these side lengths. All right, so 100 equals x times the square root of 2. Solving for x, we divide by the square root of 2. 100 over the square root of 2, we need to rationalize. What do we multiply on top and bottom? How do we get rid of this guy? Yep, square root of 2 every time. Whatever the square root is, that's what we're multiplying by. We have to also do it on the top. So 100 times the square root of 2 over 2. Reduce 50 square roots of 2. If you need to back up and watch this section again, just this part, go ahead and back it up because I'm going to move to the second type of right triangle now. So this is the 45, 45 right triangle. So this x equals 50 square roots of 2, and we have both of these sides because we know that they're equal because it's an isosceles right triangle. It's a 45, 45 right triangle. All right, let's move on. Now we are going to talk about 30, 60 right triangles. So 30, 60 right is what you'll hear me say. All right, 30, 60 right triangles come from an isosceles, or actually an equilateral triangle. An equilateral triangle, and let's say that all the sides are 2x in length. So equilateral triangle, all sides are equal length, all angles equal measure. I'm going to drop an altitude down. Actually, I'm going to redraw this because I know some of you are like, that is not an equilateral triangle. So let's get one. That one's a little bit better. All right. All sides are 2x. Now, this whole length is 2x, but when I drop that altitude down, it splits this because it's an equilateral triangle. It splits those into equal pieces. So now I also have a right triangle. So see this guy right here, right triangle. This was an angle bisector. This is 30 degrees. If this is 30 degrees and that's 90, that makes this 60 because these two have to add to be 90. Do you see my 30, 60 right triangle? Same thing happened on this side. So do you see the 30, 60 right triangle? I'm going to peel this guy off and put him over here. Okay. So this is 30, this is 60, and this is 90. So I have 2x, just going off of what I labeled over here, 2x and x. I don't know this leg. All right, so I have the hypotenuse, I have the shorter leg, I need the longer leg. Enter Pythagorean theorem, right? We've been working on that this week. So c squared equals a squared plus b squared. So c squared equals a squared plus b squared. All right, let's see if we can find this missing side. When I square this, it means 2x times 2x, which is 4x squared. Or square the 2, we get 4. Square the x, we get x squared. Equals a squared plus x squared. All right, subtract x squared from both sides. Those match because they're both x squared, and this is 1x squared. That makes 3x squared equals a squared. Now take the square root. Can you take the square root of 3 and get a nice number? No, because it's not a perfect square. Can I take the square root of x squared? Yes, that means there are 2 x's here, so they can come out as 1. Date night. All right, and that's equal to, same thing happens over here, a. So this side is x times the square root of 3. All right, so side lengths. I have 2x, x times the square root of 3. Now I'm going to show you something on this because the 45-45 right triangle is pretty nice. It's x square roots of 2, right? Legs are x and x. Hypotenuse is x times the square root of 2. This will always be bigger than these two. You're multiplying by about 1.4, whatever these are. Always going to be bigger. Coming back to the 30-60 right triangle, opposite the smaller angle is always the smaller side. So when I write down 30, 60, 90, x will be across from the 60-degree angle. X times the square root of 3, which is x times about 1.7, always opposite the medium angle, which is 60. And then 2x, 2 is bigger than the square root of 3, goes opposite the largest angle. So that will kind of help you remember what these angle measures are and the relationship between them. All right, so that means it doesn't matter which one of these I'm given, I can always find x or they're going to give me x. So if they tell me x is 3, I know this leg is 3 times the square root of 3, just plugging in 3 for x and plugging in 3 for x here. 2 times 3 is 6. Bam, got it. All right, what if they give me different information? What if they tell me this leg is 10? Then I know 2x equals 10, so x is 5. So that means this side is 5, and I plug in 5 over here, and I've got 5 square roots of 3. So if they give you x, yay, you just plug the stuff in and roll with it. If they give you one of the other two sides, you just solve for x and then plug it in and go. All right, let's try a few, and then we'll be finished. All right, let's look at this guy. So this is 30 degrees. I have a right triangle. This force is 60. All right, so I'm going to write in green, this is x. The side opposite 60 is x times the square root of 3. And the side opposite my right angle is 2 times whatever x is. So I'll write that up here. Opposite 30 is x. Opposite 60 is x square roots of 3. Opposite 90 is 2x. These are good things to memorize, although you can always draw that equilateral triangle and figure it out. But you'll work with this so much over the next couple of years. it'll be ingrained in you. All right, so they gave me x. I know that x is 11. Hey, this is plug and chug, isn't it? That makes this 11 times the square root of 3. That makes this 2 times 11, or 22. So the hypotenuse in our problem, x is equal to 22 and y is 11 square roots of 3. Wish they would not use x and y on these, but they did. All right, so there are my answers for that. All right, let's move to this one. What did they give me? They gave me the longer, this actually should be 30, and this should be 60. We'll just fix the problem. All right, they gave me the longer leg. So this is a 60-degree angle. That was a little typo. This is 60-degree angle. This is 30-degree angle. Now, if that's on the EOI and this says 30, do not change the problem. Okay, do not do that. So you just have to work it like they give it. All right, so opposite the 60-degree, remember this is x times the square root of 3. Do we know what x is? Absolutely we do. X is 21, which means this side is 21, and it means this side is 2 times 21, which is 42. So in this case where we were solving, I'll get those letters off of there real quick. So y is 21 on our triangle. This side is 21, and x is 21 times 2, which is 42. So x is 42, y is 21. All right, let's look at this one. So this is the 30-degree. They gave us the side opposite 30. I mean, opposite the 90-degree angle, 30 in length. All right, so remember, this is 2x. Opposite 60 is x times the square root of 3. Opposite 60 is x times the square root of 3, and opposite 30 is x. All right, I'm going to set this up. 2x equals 30, so x is 15, which means the side opposite 30 is 15. So in this case, it is really x. So this side is 15. This side is plugging in 15 for x, 15 times the square root of 3. So y is 15 times the square root of 3, and x is 15. All right, last one. Then we'll work some more in class. All right, this is 30 degrees. They gave us the 2x side. So 2x equals 50 times the square root of 3. Dividing both sides by 2, x equals 25 square roots of 3. All right, remember, this is opposite the 30 is x, and this is x times the square root of 3, excuse me. So going back to these. All right, so this is this side, 25 square roots of 3. So y is 25 square roots of 3. This looks like gibberish over here, doesn't it? I don't know what kind of writing that was, but it was bad. Not that you guys ever get sloppy. I'm not saying that, totally not. All right, then I'm going to plug in 25 square roots of 3 for x here. So I have 25 square roots of 3 times the square root of 3 multiplied by the square root of 3. What happens with those two? Well, square root of 3 multiplied by square root of 3 is square root of 9, which is 3. Remember, if you have the same thing underneath the square root, that square root can just pop right off of there. So 25 times 3 is 75. So I have 75, 25 square roots of 3, and 52 square roots of 3. So x is 75. All right, guys. Sorry the video was so long, but there's a lot of stuff in here. You can also break it up today if you need to. I guess I should have said that at the beginning of the video. You can figure it out. All right, guys. Make sure that you have 8-1, 8-2, 8-3, and then also following this video, 8-4 in your notebook by midweek, because we are going to take a little quiz on this, and I'm going to check your notebook. So make sure you have all of that in your notebook, not floating around anywhere. All right. This is Coach Lowe, and I'm out.